This is Laura Duncan from CSMS. Today we'll be simplifying more radicals. Let's look at number 1. When simplifying this, let's not forget our negative 5 x to the third power y. And let's focus now on the square root of 18. That's not a perfect square, so let's start by breaking it down. 2 times 9 is 18. Well, 9 is a perfect square because 3 times 3 is 9. Remember how we talked about yesterday that 2 become 1 out in the sun? So on the outside of the radical, we're going to have 3. On the inside of the radical, we'll have this leftover 2. Now let's look at x to the 5th power. That's not a perfect square. So we'll take 1 away from the x and leave it under the radical. Now we're basically finding the square root of x to the 4th. We divide by 2 to simplify that. And finally, we'll look at y to the 6th power. That is a perfect square. Now that we've simplified the radical, we need to multiply. So we're going to multiply the coefficients and add the exponents. Negative 5 times 3 is negative 15. X to the 5th power, y to the 4th, times the square root of 2x. Box, cloud, or circle your answer. When we're solving problems like number 2, sometimes it's easier to leave them together and solve. For example, you can see that these are both divisible by 2, but that doesn't work this time. This time it's easier to separate them and solve. So we could rewrite this as 64 times g to the 18th, finding the square root of that, over the square root of 8100 times h to the 20th. And these happen to both be perfect squares. Since they're both perfect squares, that's when we want to separate them. The square root of 64 is 8. The square root of g to the 18th is g to the 9th. Those are both perfect squares. The square root of 8100 is 90, and the square root of h to the 20th power is h to the 10th power. Before we box our answer, we better make sure that it is simplified, but both of these have a 2 in common. So let's simplify those. It would be 4 over 45. And there's no way to simplify the g and the h, so we will leave them as they are. On number 3, when deciding whether to separate these or to solve them as they are, we're going to look for a perfect square first. Since there's no perfect square, we're going to try to simplify this. So we're basically finding 363 divided by 3. That would be simplified to 121. Now under the radical, let's go ahead and simplify this. Since we're dividing, we're going to subtract. 5 minus this understood 1 would be x to the 4th. Now notice that y to the 3rd is in the denominator. It is larger than y to the 1st power, and we're subtracting. So that would leave y to the 2nd power in the denominator. Now we're finding the square root of all of this. All of this is under the radical. Now that we have broken them down into perfect squares, now we can separate and solve. So we'd find the square root of 121 times x4, and we'd find the square root of y squared. These are perfect squares. So the square root of 121 is 11. Square root of x to the 4th is x squared, and the square root of y squared is y. That's our final answer. Number 4 is a little bit different than the ones we've been working on. This is an equation. You can see the equal sign, and it says that we're going to solve. Well, remember that to solve an equation, you must do the opposite. Well, what's the opposite of squaring a number? The opposite is square rooting. So we're going to take the square root of both sides. The square root of x squared is x, and the square root of 100 is 10. However, it's not at first obvious, but there are two answers to this problem. Because if I had 10 squared put into the original problem, that would give me an answer of 100. What other thing squared would give us the answer of 100? Well, negative 10 squared would give us a solution of 100. So on these types of problems where you are asked to solve and you're given an equation, there will be two answers, both positive and negative 10. You can write it that way, or you can write that there is 10 and negative 10. Both answers must be present. All right, notice on number 5, we have another equation. We're being asked to solve. So we will do the opposite to isolate the m. We'll have 2m squared equals 98. We need to isolate the m some more, so we'll divide by 2. Now m squared is equal to 49. And you may say, woohoo, it's a perfect square. And you may write down m equals 7. But you wouldn't be completely correct. Why? Remember that there will be two answers. Positive 7 and negative 7 will work to satisfy this equation. The final problem of the notes. Let's solve this by doing the opposite to each side of the equation. So we'll add 500 to both sides. This will cancel out, and so we'll have 45a squared equals 500. We'll divide by 45. In order to have a 1 here. So we have 1a squared equals 100 over 9. Now to solve for a, we're going to do the opposite of squaring, which is finding the square root. The square root of a squared is a. Now we're left with the choice to leave them together or separate them into separate square roots. Since you cannot simplify 100 divided by 9 to get whole numbers, then we're going to separate each of them. We'll find the square root of 100 over the square root of 9. So a equals, the square root of 100 is 10. And remember that the square root of 9 is a perfect square, 3. But don't forget, there are two answers. Positive 10/3 and negative 10/3 are both solutions to this equation. The lesson is yours.